Welcome to the Explainer. So I want you to imagine, just for a second, that your upcoming Cambridge physics exam is actually a high-stakes cricket match. You are the captain out on the pitch. The examiner? Well, they're the bowler, and they are constantly trying to read your weaknesses, throw a tricky spin your way, and get you out. Your goal is to read their spin perfectly, set your field, and systematically score every single available mark, or in this case, run. Today, we are completely decoding the examiner's mindset using the fundamental concepts of mass and density. We're going to completely transform the way you approach these papers, shifting your answers from basic rote memorization to top-tier examiner-approved analysis. Whether you're sitting syllabus 0625, 0651, 0652, 5054, or even looking ahead to your A-levels with 9702, this strategy is absolutely going to change the game for you. But before we dive deep into exam technique and start looking at rubrics, we really need to start with an application-first hook. Because let's be honest, the absolute most effective way to learn physics is to prove to your own brain that these concepts are entirely necessary to everyday life, not just decorative facts that you have to memorize for a test. So ask yourself right now, what physical effect out there in the real world actually depends on mass and density? Think about it for a second. Why do we even care? Well, we care because whether a colossal multi-thousand-ton cargo ship floats or sinks to the bottom of the ocean depends entirely on its overall density compared to the water it sits in. We care because the fuel efficiency and flight capability of a commercial aircraft are completely dictated by the mass of the materials used in its construction. Mass and density are the invisible rules that are literally governing modern engineering, global safety, and international transport. Once you truly understand that these core concepts are used to solve massive, real-world problems, the formal language and the mathematical formulas become so much easier to reason through, especially when you're suddenly faced with a completely unfamiliar, panic-inducing exam question. All right, let's look at exactly where students are bleeding marks in the exam hall. I want to introduce you to two archetypal students. Let's call them Alex and Sam. They are both responding to a very standard past paper question, asking them to explain why a solid steel block sinks, but a wooden block of the exact same mass floats. Now, take a look at Alex's approach on the left. Alex is what we call a knowledge dumper. Alex overloads the answer with raw physics facts, writes down the formula for density, defines mass perfectly, and meticulously lists out all the standard units. But here's the problem. Alex offers absolutely zero analysis of the actual wooden and steel blocks mentioned in the specific question. Now look at Sam on the right. Sam's a rusher. Sam completely ignores the crucial command words, which in this case would be explain or compare, and just hastily writes, "Wood is lighter so it floats," hoping for the best. Sam gets absolutely 0 marks for reasoning. Both of these answers fail miserably because they do not link physical cause to physical effect. They are basically walking out onto our cricket pitch entirely blindfolded, swinging wildly and hoping they hit the ball. Let's move into Section 1, the strategy reveal. It's time to take the blindfold off and actually learn to think like an examiner. If you want to score maximum marks, you have to realize something absolutely crucial. The examiner is literally sitting there with a strict rubric that demands very specific logical connections. They're not just looking for true statements, they're looking for a cohesive argument. Top-tier students don't just know the physics inside and out, they actively structure their answers to mathematically capture every single available assessment objective. This exact 4-step sequence you're looking at is non-negotiable for top-tier answers. The examiner is waiting for you too. Number 1, identify the specific physical quantity or phenomenon. Number 2, state the relationship involved, like a recognizable formula. Number 3, explain the underlying physics by building a concrete cause and effect chain. And number 4, crucially, connect it all back to the specific observation, experiment, or device mentioned in the prompt. If you just drop a formula on the page and run away, you've only completed step 2. You have to take the examiner by the hand and walk them through the entire journey. This sequence is what actually proves you understand the why and the how, not just the what. Now, to make this incredibly easy to recall when you're under extreme pressure and the clock is ticking down, we simply overlay those 4 steps directly onto the Peel framework. You might already know this structure from writing essays in English or history, but let me tell you, it is devastatingly effective in Cambridge physics exams. Point: define the core physics idea right out of the gate. Evidence: provide your specific relationship, your equation, or your data points. Explanation: build that crystal clear cause and effect chain. Tell the examiner exactly what changes physically. And link: connect it directly back to the practical use or the weird observation the question threw at you. By intentionally forcing your answers into this rigid Peel structure, you naturally and effortlessly hit all 4 steps of the examiner's rubric. You literally cannot miss the marks if you follow this path step by step. Okay, challenge time. Let's see if you've got this. Take the next 30 seconds to mentally spot the correct application of our Peel framework in these two mock answers. Option A says density is mass per unit volume. Steel has high density, so it sinks in water. Option B says the core idea is density, which is mass divided by volume. Because the steel block has a greater mass compacted into the same volume as the water it displaces, its density is higher than water. Therefore, the physical effect is that the downward force of gravity exceeds upthrust, causing it to sink. Look closely at both. Which one is actually hitting point, evidence, explanation, and link? If you chose B, you are exactly right, and you're already starting to think like a Cambridge examiner. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, moving into Section 2, the transformation. Let's take those terrible red pen answers from earlier and flip them into solid green check marks.
We are going to apply our newly revealed strategy to show you exactly, step by step, how to salvage a fundamentally weak answer and sculpt it into a flawless, maximum mark response. The ultimate weakness in physics exams, the thing that makes examiners groan and reach for the red pen, is when a student drops a formula without defining the variables or quotes a physical process without ever linking it to a tangible physical effect. The official Cambridge Examiner commentary explicitly warns against this year after year. The SAFE method, the one mathematically approved by examiners to secure marks, demands a clear, unbroken cause and effect chain. Instead of just lazily writing density equals mass over volume, the SAFE method requires you to write, as the mass of the material increases while the volume remains constant, the density increases, which results in, you have to show the physics actually happening on the page.
Let's put you directly in the hot seat for a 60-second rewrite challenge. I want you to mentally rewrite Sam's terribly flawed answer from earlier. Remember, Sam rushed and just wrote, wood is lighter, so it floats. You have a theoretical 60 seconds starting now. I want you to apply the SAFE method. Think through it. What is your point? What is the evidence? How do you effectively explain the physical cause and effect? And how do you finally link it back to the water? Formulate that entirely in your mind right now. You need to aggressively move away from everyday conversational language like lighter or heavier and move confidently toward precise physics vocabulary like mass, volume, and density.
Okay, let's look at the incredible transformation you can achieve here. Before, on the left, we had the red pen disaster, just dropping raw formulas or using vague everyday words that mean nothing in physics. But look at the after. Look at the green checkmark answer. Wood has less mass per unit volume than water, meaning its overall density is inherently lower. Because its density is lower than the fluid it displaces, the resulting upthrust is sufficient to support its weight, causing the physical effect of floating. Do you see the massive difference in quality? Moving away from everyday language and leveraging precise physics vocabulary, defining your variables clearly and explicitly linking them to the final physical effect is exactly what magically adds those crucial marks to your score. You are definitively proving to the examiner that you deeply understand the mechanics operating behind the visual observation. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions. Welcome to Section 3, the Interactive Workshop. It's time to put mass and density into intense action under simulated pressure. Let's kick off with Challenge 1. I need you to rapidly scan the data provided for steel and aluminum. Notice that both materials have the exact same volume of 1 cubic meter, but look closely at the mass column. Steel sits at a whopping 7,800 kilograms, while aluminum is relatively light at only 2,700 kilograms. You have under 60 seconds to extract the absolute core physical trend hiding in this chart. What is this data actually screaming at us? The unavoidable trend is that for a strictly constant volume, the material with a significantly higher mass inherently possesses a proportionally higher density. This isn't just trivia. This is exactly why cutting-edge aerospace engineering relies so heavily on aluminum alloys instead of steel. They desperately need the structural volume to build the plane, but they cannot afford the massive, fuel-guzzling weight penalty that comes with steel's density.
Now brace yourself for Challenge 2. I need you to play the role of the examiner and find the fatal flaw in this specific statement. The metal's mass increased, therefore the density changed, making it heavier. This is a classic, brutal trap that so many bright students completely fall into during the panic of an exam. What is fundamentally scientifically wrong with this sentence? I want you to think really hard about intrinsic properties versus extrinsic properties. Does simply adding more of the exact same type of metal change its actual inherent density?
And here is the official examiner commentary absolutely tearing that flaw apart. That statement completely, totally misses the real physical cause and effect. Density is an intrinsic property of a material. Think about it. A tiny 1 kilogram block of solid steel and a massive 10 kilogram block of solid steel have the exact same density, period. Increasing the mass simply by adding more of the same material also increases the volume proportionally, which means the ratio, the density, remains perfectly constant. You can never, ever just string random physics words together like mass increased, therefore density changed, without a valid mathematical physical justification. Now, if you were to compress a gas into a much smaller volume while keeping the mass the same, yes, absolutely the density changes. But for a solid block of metal, absolutely not. You must link your stated process accurately to a valid, provable physical effect.
Let's initiate Challenge 3, Speed Writing. Under simulated ticking clock exam time pressure, can you write one utterly perfect Peel paragraph explaining why a hot air balloon rises, specifically utilizing the concept of density? Point, evidence, explain, link. Go. Think fast. The heat from the burner increases the volume of the air trapped inside the balloon. Since the mass of that trapped air is effectively constant, the golden equation, density equals mass divided by volume, tells us mathematically that the internal density must decrease. Because that internal density is now significantly lower than the cooler, denser air outside the balloon, the entire structure experiences a net upward force, or upthrust. Boom. That is a perfect, bulletproof, maximum mark response crafted in a matter of seconds, all because you systematically use the framework. Finally, let's bring it all together in Section 4, the final system and memory prompts. First, I really want to remind you why we are doing all this hard work. Physics is absolutely not just an arbitrary hurdle invented for Cambridge exams. Mastering fundamental concepts like mass and density is what actually allows human beings to predict and drastically improve outcomes in all of these critical real-world fields. Whether it is designing vastly safer transport by meticulously calculating crumple zones with very specific material densities or engineering groundbreaking medical technology, these are the fundamental, unbreakable laws of reality. A truly top-tier physics student should always be able to name at least one real-world situation where the concept they're studying actually matters. When you deeply understand a concept's application in massive energy systems or even astronomy, the tricky exam questions suddenly just become fun little puzzles, simply asking you to apply what you already know to be true about the universe. So here are the 3 definitive, unbreakable rules of our physics success blueprint that basically guarantee top marks on paper 0625 and beyond. Rule number 1, command word decoding. You must never, ever waste time answering an explain question when the prompt only asks you to state. Rule number 2, Peel framework application. You must always use point, evidence, explanation, and link to methodically build those undeniable cause and effect chains. Rule number 3, the time management matrix. Please do not spend 5 agonizing minutes on a tiny 2-mark question. You have to intelligently allocate your time based strictly on the marks available, knowing full well that a beautifully structured Peel paragraph can cleanly and easily secure 3 to 4 marks in just a couple of minutes of writing. And to ensure this framework actually sticks in your brain permanently, you need to use memory prompts. Whenever you sit down to revise a micro topic like mass and density, you must be able to confidently answer these 4 specific questions aloud. 1, what is the core idea at play? 2, what actually changes physically during the process? 3, what mathematical quantity or specific graph demonstrates it? And 4, where is this actually used in real life? If you can articulate the answers to those 4 questions clearly to yourself, your knowledge is completely, undeniably secure for both those tricky short answer questions and the long structured exam questions. You have officially read the bowler's spin, you've set your field, and you are completely ready to strike. Now, the number 2 on screen here is incredibly important for your future. Students who implement these exact physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. That massive jump is literally the difference between walking away with a C and walking away with an A.
But again, that monumental improvement only happens if you are willing to practice consistently and diligently apply this exact Peel framework to every single past paper you attempt from here on out. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.